Okay, finishing up the problems from chapter 3, so 3H3, 3H4, and 3H5. So here's the question. We'll get to it in just a second. But before you go there, make sure that you have ran the code for questions 3H1 and 3H2. Okay. So in questions 3H1 and 3H2, watch the video for that. But the basic premise was that we had a data set that had the sex of the firstborn and the sex of the secondborn, right? So these are families that have had 2 kids, and it records the sex of the first and the second. Okay. And in that problem, we were basically asked to find the maximum value of the posterior distribution that predicted the probability of either child being male. Okay. And in question 3H2, we found some high probability density intervals for that. Okay. But now from here on out, we're going to be, so we have this model that we used to create all of this, and now we're going to be checking that model with these posterior predictive checks. And so the first check that we're going to use is we're going to replicate our posterior distribution. So we're going to generate fake data from the posterior distribution that we already found and look at and try to see how similar it is to our actual data. Okay. And so the way that we're going to do that, so I'm creating this object here that's called replicates. Be careful because there is a command in R called replicate, which is just without the S there. And so we're going to simulate from a binomial distribution. So R means random, so we're going to randomly generate binomial samples. Okay. We're going to generate 10,000 data sets of 200 observations, and the probability of a boy will be determined by the previous posterior distribution that we have sampled from and called those samples samples. Okay, and so at the end, what you get is a vector of 10,000 elements, and each one of these is a simulated data set with the number of boys that were in that set of 200 births. Okay, and so we're just simply asked how close does our data look compared to what we're generating here. So so I'm going to simulate in 2 ways. One by the way that is suggested by the question with this DENS function, and then also a histogram, and well, you'll see what they look like here in a second. So here is the histogram of my posterior predictive distribution. Again, watch the earlier videos if that term is unfamiliar, and here that same distribution is in terms of a histogram. And this black dotted line is the probability of a boy. Okay, and so we're asked how similar is the data we observed, the black line, compared to what the model expects. It's pretty much right in the middle, and this shouldn't really be surprising, just given how simple this particular model was. But so far, our model seems to pass this first test, and we say that's great. But we can start to dig in a little bit deeper, and that's what we do with 3H4. So now, instead of comparing both births, the firstborn and the secondborn, we're just comparing the firstborns. Okay, and we're going to see if somehow our model is still doing a good job of predicting just the firstborns. So this is interesting because what would it mean if it didn't predict well the firstborns? Okay? And then ask yourself, what would it mean if it didn't predict well the secondborns? Okay, and so we're actually going to, so the question just asks us to do firstborns, but we're going to do both first and secondborns. Okay, so we're just repeating the code, but this time instead of a sample of 200, we have a size of 100. So every data set that we generate will be 100 births instead of 200. Okay. And then I'm going to plot those in much the same way that we've already plotted them. And so here it is. Okay, so I should turn that gray like the previous question. And then again. Okay, so the background spread here is our posterior distribution. Or I'm sorry, our posterior predictive distribution. Okay. And then the dark blue line is the firstborns that were male, and then the light blue line is the secondborns that were male. Okay. And so there's some, this one I guess is a little bit easier to see, so now we're asked, how well does our model kind of fit the data that we're observing? And that depends on what you mean by how well. It depends on the application of your model, what you need to use your model for. But I guess as a first pass, I would say, well, they're both more or less in the bulk of the distribution, so I guess maybe it's doing okay. But if I was going to speculate a bit, I would notice that whereas the dark blue line is pretty close to both the peak of the posterior distribution and 50%, right? So it's kind of in the middle there. The light blue line seems to be skewing a little bit. And so the question is, okay, well then, why? And so the first thing that comes to my mind is, okay, well, it makes sense that this firstborn is not really being affected too strongly one way or the other, whether the firstborn is boy or girl. But maybe one of the things that's determining the sex of the secondborn is the sex of the firstborn. Okay, and we're going to pick that up in the final question, 3H5. So in question 3H5, you can read the question for yourself, and we're going to address the question, but I'm going to expand on it. But first, so what we're trying to do is to see how well our model predicts the secondborn, right? Especially because in the posterior predictive check above, it seems like it's possibly not doing a great job of predicting that secondborn. So I'm going to partition out my data. So I have the secondborn after the firstborn was a girl, and I'm calling that after girl. And then I have the secondborn, the sex of the secondborn, after the first birth was a boy, and I'm calling that after boy. Okay? So I'm creating replicates for both of these replicate data sets. Okay. Again, just like we have before, but I'm only using as many observations as there were girls in the firstborn girls, and for replicates after boys, I'm only using, again, my data only has as many observations as there were boys in the firstborn boys in the actual data set. Okay. And so now when I go to look at this, so again, we have our, I should make that gray, just to be consistent. Sorry. Okay. Oh, well, now I've messed something up. Hold on, let me fix this. Okay, fixed it. So again, we have our posterior distribution in the background there, our posterior predictive distribution. Okay. And now we have the number of boys in this light blue line here. We have the number of boys given that the firstborn was a girl. And we notice that this is way out of bounds compared to what the model expects. And similarly, it way underpredicts when the firstborn is a boy. And so this is, again, interesting. It makes it more plausible that the sex of the firstborn is affecting the sex of the secondborn.